me I am live for the past 8 seconds. Here we go. Yep, that looks like it's live. Can't find my headset, so I can't do a sound check. But welcome to another stream. Okay, I can't remember what we were doing last time either. Let's go there and have a look. Looks like I was doing a bit of coding. I suspect I was looking at doing a bit of C++. I think it was a week ago, but we shall see. Right, what are we doing? Today I'm trying to get back into streaming again, and what we're going to be doing is having a slight change of tact. Not quite sure why, but a few days ago I just sort of stumbled back into Rust. Excuse me, I'm also still recovering from a cold. Okay. I'm just opening up C-Line, which has decided to go somewhere other than on the main screen. There we go. Let's bring you over here. All is going on, it's doing some rusty stuff. Okay, so the story is that welcome to C-Line 2019-3. Really should think through what I'm going to say. We'll get better at this stuff. The oh dear. Right. Recovering from the flu, and 90% of people in this house are currently ill, so I'm likely to come down with a cold soon. That should be better. Hopefully that won't max out your speakers anymore. Past week or two I've been some coding. I've been quite into C++. Really enjoying it actually, but I was walking home the other night, and a few nights back, and it was dark. I didn't put my headphones on. You know, you relax, you're thinking, and Rust just sort of floated in. I was like, I should do some of that again. Have a look at it again. I mean, I've done it a few times, done little dives into it, and I thought, so I had a little play, and I enjoyed it. A lot of my problems were disappearing, and the compile times are either faster or I'm just more tolerant of them. I don't know. I wouldn't say they weren't hugely, they were not hugely fast compared to C. Okay, so we're adding a cargo command at the moment. Just call that run. And I was also thinking about Haskell. Run. Command to run. Yeah, so just run it. Edit. What's the problem? No working directory specified. Oh, just pick the default. My name's Paul. You can see it's awesome. No Rust toolchain. Do I have Rust installed? Rust toolchain. Well, I suppose Rust C. Here you go. I know I've got it installed. Should be. 139. I know it's got installed because I did a cargo create, so I wonder if I've got the Rust plugin installed. Oh, I'll get back to the story in a minute. Settings, I guess. I'm not that familiar with C-Line. Editor plugins. Type to see Rust. Oh, it says it's installed. Installed. Well, this is not going well. No Rust tool chain. Normally you can get away with that. Okay, tool chains. We probably don't have many. See whether we can. We've got a dark theme. Language and frameworks. Toolchain. There you go. I don't know. Oh no, not standard library. Not really sure what I did because it just defaulted to everything anyway. Clearly just needed to go there. I think it has to go way back in. I remember trying to learn it in early 2000s, 2002, 2003. And one of the things I really liked were types. And Rust kind of improves on C++ in terms of its types. So I thought, why not have a go at it? Now, usually when I have a go at Rust, I just give up. I don't find it as productive. Now that's not a comment on the language, it's normally a comment on the libraries, they're not quite there. But I figured I would try and just write something in Rust, just not read the book again, although we should probably open that up to know it's there. Rust book. When I say the book, I mean this book, which is the one that you learn from. And we will probably use search quite a lot, which is great. Where were we? Oh, excuse me. So we've done all that. Where are we going? Then I thought, just going to try and write something, and I'm going to commit myself to only using Rust for a couple of months. Change font zoom. Yep. Here we go. If that works on there. It does work on there. Let's have that up a bit. Now I don't know what volume I should be talking at. I keep saying I don't know. Yes, if I talk quieter, that's okay as well. So I'm going to try and write an interpreter. It's one of my favourite things. I've got many streams where I've tried to write it. In fact, I tried to write a Rust one way back in February, and then jump back into C++. Wasn't very productive. Now part of that was I was struggling with iterators and converting them back to slices. I think I've got a slight handle on that now, so we shall see. Saying the word C reminds me of the other thing I think that's all down. Lifetimes. I think about lifetimes, and I like to code programming C, pure C, rather than C++. And one of the things there is you do spend a lot of time thinking about lifetimes of objects and how they're clumped together, and using arena allocators and things like that. Now I know Rust is not quite so easy to do arena style allocators, but that's not a problem. Well, what it was analogous was I was manually thinking through a lot of stuff which the type system could with a little bit of help of lifetimes, help me with. Now, if you do C properly, it doesn't actually get complicated because you do arenas and you think about groupings, and the number of things that you're tracking in your head is fairly small, as opposed to C++, where you can do a lot of per object allocations. Doing arena allocators is slightly more difficult, mostly because you might have destructors and all that sort of fun stuff. Although NZAT 17's made a lot of these things a lot easier, so C++ 17 is pretty good. So I am rambling. My brain is not. Let's change that to hello Rust. We're going to write an interpreter. So the first thing we're going to want is a lexer. And in that we're going to have some code, and it's going to be a reference with a lifetime, and it's going to be str. Is that how it works? No, that doesn't know because we don't know about it. I can't remember what goes here. Simply go there. And finally we're going to have an iterator. It's going to be jars, which it does not like. Using lifetime specifier. Because of iterator, something like that. Okay. Now we want a function. Let's got to think about pressing T there. Code. Don't need any of that. And iter equals not equals. Right, we should have some lifetime troubles for that. Now I believe you have to put lifetimes everywhere. Okay, that seemed to work. We run it. He's fine. So what have I done? Created the structure. Like I said, I'm not new to Rust, but I'm not familiar with it in any form whatsoever. I wrote about 20 lines, 50 lines the other day, and other than that, I haven't touched Rust for about 4 or 5 months. What I have done is think about Rust a lot, so I'm not happy with lifetimes. And I do read the Rust Reddit sometimes, so excuse me, I'm getting water all over a notepad that I don't really want to get water all over. Put on that notepad instead. So, we import chars, which is an iterator over characters in a string, as opposed to... I don't think it's UTF-8 friendly. I'd have to check. In fact, the point of this stream is to do checks. What are Rust chars? Iterator over chars, which is of a string size. Chars are a single character. A char is a Unicode scalar which is similar to but not the same as a. So this is going over, I would assume, yes, so it is breaking up using UTF-8 code points chars. I can't remember. Not similar to code point, use scalar value. Who the hell knows what that is? I can't remember my Unicode. But anyway, it's a it's not necessarily single byte, it could be up to 4 bytes. Unicode code point except high scope and low scope code points. In other words, the range is blah 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 blah. Doesn't matter to us. So yes, so we don't need to worry about UTF-8 stepping or anything like that. and we're not going to want to index anything. So, we're just UTF-8 friendly. Now, where was I? So we've done that with jars. We know it's a UTF-8 friendly thing. UTF-8, yeah, probably. Create a structure called lexer, which is going to break up the string code for us eventually. In it, we want a reference to the code, which we're going to have a str for. A str, which is basically a string view if you're a C++y person. If you're not, it's a pointer to the start and its length. And it can be a substring, subpart of the string, so it's a slice of a string. Code probably uses slices, I don't know. And we have an iterator over all the characters. Scalar code, scalar, Unicode scalar points, or whatever we call them. Rust separates the declaration of member values with the functions that are on it. So we've just made a new one there. No. Let, which is a const. We're going to want to mutate this because we're an iterator, so let mute. Lex equal new. There's no self on the new, so it's a static function. In C++ terms, we wonder what it is in Rust terms. Let's just do plus minus 1, 2, 3 A, B, C, D. Cool. Now that should build, and when we run it, nothing should happen. Cool. So what we want to do is we want a next, so fn next, and now we want a self, so self, and I think they do that, or not, mute self, next, that's what we want, and we want it to return a token. For now, let's just have an enum token. We might have found it in add, subtract, number, identifier, not a subtract, hash, derive, debug. Cool. So what we're just here is this bit here where it says token is add. What do we do? Well, we added an enum, which is at the moment a basic enumeration of add, subtract, number identifier. These tokens are proper type, unlike an enum in C++, more like an enum class in C++. They differ in C++ in that you can add member variables to them, so you could do something like because it won't compile, something like that. So if we want to store some additional information, which we shall make great use of soon, then we can do that. We'll also, for instance, an identifier will want to know, or a number will want to know the slice of the string that represents a number. We're not necessarily going to convert it to an integer straight away. And it's not even late, I'm pretty tired. so I apologise. And then we added a next function. This is reminiscent of an iterator. We may eventually wrap all. Well, we may eventually make it an iterator. Which would be pretty good. But for now, you know what? Option. Because in a minute we're going to want to. Is that right? Yeah. So at the moment we make it optional. So when we finish, when there's no more tokens, it returns a none. Is it a none? Knocking the semicolon off the end returns the value, so that would be an error. When I build that, it will say nah, and because it's great, this returns these two braces means null type. Consider removing the semicolon, so the awesome errors that are roughly famous for. Okay, we've got lots of warnings, but let's not worry about that. Right, that's pretty cool. Now begins the fun. Right, first of all, let's make that none. So if we get there, it doesn't. Let I equal iter.next, and there's no implicit this, so or self. If let some chr equal I, else none, okay, so what are we doing here? We're getting the next value from the iterator, so hopefully that will be a plus, and then we return the plus or return the none. Most things, everything's an expression in Rust. Most things, some things probably aren't that I don't know of. So this is effectively the same as doing which is also fine. You return some add, but so the last expression is being returned, and that's an if, and as long as we always return an optional token, everything's happy. Equal to the bottom value. So match is like a switch statement on steroids if you're from the C++ world. So we're not. Nope. That's probably going to get changed to what? Rust lets you do is ranges. remove the parenthesis. So it's gone wrong there, hasn't it? No variant or associated item name plus found in token in the current scope. Brought in due to error. See what my error says. Okay, that did not tell me anything. Close tabs. And you would not expect that to work. Yep. Okay. Add, subtract. Let's rename that to plus, and that to minus. And then let's rename it again. Put that on there. Okay. Recap. We've gone this way to get a value from it. This little expression says if it takes I, if let, which tells us we're going to do some form of matching. If the matching fails, we go into the else part. We're going to try and match thumb char, I suppose, and we're going to do that by assigning equals to it. This would be slightly similar to destructuring in C++, but not at all, because the matching can fail and move on, whereas destructuring, the auto square brackets thing never fails because it's type checked. So in this case, we're trying to match the situation where we have a value in the optional. When we don't have a value, it goes to none. When we have a value, we get the value out, which becomes a variable char. Then we call match. Everything's an expression. Match returns a value, so what we've just written is the same as writing that. I'll probably put a semicolon there. Cool. We don't need to because it's verbose and not needed. We match a plus and we return a token plus, a minus and return a token minus. Then we do a range. We start with a 0 character, then we set the range, and this little bit here is saying including this value. If I didn't include it, it wouldn't match a 9, and that goes to some token number. Okay, cool. Well, that's working. So let's let thumb top equals next token. So again, the let lets us know we're pattern matching. The while is obviously a while loop, so while let, ignore that. The return value of next is the sum time in item containing tokens. So if next returns a non-empty value, so it's got a sum. I'm not sure the terminology. Something. It's got something. Then we get the value out and put the value into token. So this time we're returning an optional token. So when we have the value, when we have a proper token, we will get the value of the token into token, and then we can print it. When next returns none, this match fails, and we exit the while loop. So that's not a good explanation, but given I haven't programmed in Rust for a little while, and as you can see, we've got a couple of things, but we did not skip the white space. Two ways I would do it recursively, which I don't like, or Do not need braces. So what I want to do is skip white space. Char. Not sure that's moving a value, but let's find out. Ooh, I wonder what the difference is. That's looking an awful lot like we have some looks an awful lot like not click. Next, so skip white space. You see an error there because by default everything's const. So let mute I equals self iter next while it's on white space. Let's see if that compiles, because I'm not convinced it does. Yes, it did. I will probably break that out. So what have we got? We've got number, number, number. What we actually want is the number 1, 2, 3, which is not what we've got at the moment. So we want to return a slice. What does a slice mean? We have to think about time, lifetimes. Great thing, compiler's going to tell us. Now we need to put something into this, don't we? Well, we can do it's obviously not well, that obviously is right. Okay, so what do? We just added a same number can contain a slice in a string. To do that, we need to say how long it's going to live for. So the slices or straws are not owning objects. They are views onto a string or some constant. I want to say string, I want to say char star. They are views onto sequences of characters that are managed in strings or are statically declared within the executable. Now, because they're managed in strings, they can go away, because when the string goes away, it gets deleted. Rust is type safe, memory safe, so its type system, would you say type system? It's lifetime checker, which is part of the type system. Should have to check that. Right. Emacs. absorb mode. Looks pretty good. There you go. It's a question. I'm not planning on looking that one up just yet, but I shall know before we finish this project. I think it is, but I'm talking. So where was I? So we don't want a token that can outlive. Sorry. See, no, it's doing that. That can outlive the string that the number, text view, string view, the slice contained in the number. That didn't quite come out right. A token cannot outlive the string that it refers to inside the number, or in a second inside the identifier. That means if I did something like no, I'm not going to bother doing that. We get a compile error. So if I did something like this, and then I had a mutable token here, which I now in C++ this is valid because next returns the unwrap. I'm going to assume that it isn't doing anything crazy like an empty one. Ignore the unwrap. Next is returning an optional type, so we unwrap it to get out an optional token, so we unwrap it to get out the token value. That assigns it into here, right? And that's fine because it's taken a copy. It could have a copy of a number which in turn points into this string. This string, if it was a proper string, go. In fact, let's make it really 1, 2, 3. Okay, now I think this will not compile. What I think is happening is this specifies the lifetime, which is down to here. This lifetime of the code is set up in here, so the lexer has a similar lifetime. We do lex.next, which returns a token, which assumes a lifetime from this guy. We try to assign it into A. A has a lifetime of this whole area, whereas the code, which is specifying the lifetime of this A, only has this one. this bit of lifetime, this lifetime is smaller than this lifetime, and A has to have a lifetime that is equal to or smaller than code. Let's find out. No variant or association. It doesn't actually help me. Oh well. That's because I've done add instead of plus. Well, holy moly, how does it work that out? That surprises me. Maybe because totally flummoxed. Maybe because we're not using it, it doesn't get read, so it's safe. Yes. You go, borrowed value doesn't live long enough, so this borrowed value, which only lives to here, it's been used in here, or potentially moved in here, used in here, therefore it's invalid. Clearly, because it knew it wasn't being read from, it let it through, which is kind of nice. So this should also complain. Yeah. Right, let's go back to what we were doing. Let's not have that. Not that. Hello, hello, hello. Okay. Right, you can have code blocks. Again, code blocks return values. So the last one, which is this, returns a value. Put that on. And it no longer returns a value, no longer build. There's a little message telling me that. Error mismatch types. Nil is being returned. That gives me the start of any match that we do. Actually, you know what? It doesn't quite, does it? Yes, it does. And then actually, I'm going to go over this. ASCII digit. I only want to support numbers. I think 0 to 10. In fact, yeah, that's fine. Break. Now, I suspect there's a better way of doing this. If I do a take while, I always get a different type of iterator back. So if I did something like, what I really want to do is self.iter equals self.take while, it returns a different iterator. It annoys me. Predicate, I don't know how to do lambda functions. BDA, closure by example. I could have guessed that. What's that complaining about? See, cannot move because it's mutable. Blah, 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 blah. Too much effort. Just write the while loop. I will eventually learn it more in-depth iterators, but probably by reading other people's code. Do it by hand. Well, we've got some match to a chart, and if it's an ASCII digit, break. Otherwise, keep on reading. Skip past the digits. Ignore decimal points and all that stuff. We're not worried. Now we're worried about this because we don't want that. Right, so we've got the start. So we're saying, yay, start from here and then go to so the iterator's moved along a bit, so its total length is going to be slightly less. So if we do start, then we get the length of the string from this. So we have we've called the start, where we start matching something, and that's a slice that goes from where the current iterator is to the end of the string. So that might be 1,000 characters. When we get to here, we skipped over the digits, so we've moved from here, moved along, say 3, so we've got a 3-digit number, and then we get the length from this position all the way to the end, which would be 997. The difference is 3, so we can create a slice. This I spent ages working out in February and couldn't get it. I ended up having to use strings, and strings are allocation prone, and I didn't like it, and that's one of the things that put me off. Wouldn't sound super keen on the way this works, but it's not as bad, and there is no well, that doesn't look good. Two. Which is terrible. I wonder if this debugs very well. Because that'd be fun. Full screen. Right. Let's have a look at the self. It's already a 2 here. Now the problem is we've got to think about a white space. One, two, good. Okay, so we move it along, and then we move the start along, and that should not matter. 1, 2, we've got a 3. 2. One, 2, and we've not got that. And your number is that, if not a digit. 1, 2, 3, space. Guess we need a -1 on that. That seems a bit dubious to me. Do a nice sprinkling in. So if that was 10, 9, 8. I think that will come back and haunt us at some point. But that is fine. And we don't match anything else because we haven't got any identifiers, right? So let's get that checked in. Start of interpreter. Not doing too badly, given I don't know what the hell I'm doing. We need to match a dot equals the. That's a good identifier. to Z, B to Z. I think just need to do a self there. That's what I wanted. Oh, you see, that's interesting. Yeah, okay. Right, so if it's not alphanumeric and C not equal to underscore, get out of there. And what have we got here? We need to allow that. Okay, cool. And you have a problem as well. I think we're still getting the numbers wrong. If you notice, it's dropping the O off there. I don't know what that is. Let's take that away. See, instantly you're worried about these ones and stuff. Well, I am anyway. Just took it off the wrong one as well. Boom, boom. Why are we doing this? I do not know. Right, so we have a problem that when we hit the end of the string, it doesn't match, but that should put us onto the null terminal effectively. See that? Len is 5. Don't think it's going to let me do the whole print. Oh. Okay. So that's always on the net. Right, I'm arriving at a solution that I may not be totally happy with. Iter equals self dot iter dot clone mute. I'm looking to iterate advance. Oh God. Skip doesn't do what I think it was meant to do. Skip 2. That's what I expected it to do. Why would you? Right, let's write this as 4 iter, my goodness, it's 10:30, which on a school night is getting late for my head. Oh, still streaming, that's good. For loop range, probably. Cool. What if I can? Yay. some pretty ugly code. It's working. Now we need to take this. Let's keep messing with that a bit. You see something I'm wondering whether I need that. Because it only ever moves to that one where the end slice trails behind. I could keep doing it as an iterator, but I'm going to need to slice anyway, so which may mean I don't need that. Awesome. Get rid of some of the junk code. Cool. We seem to be working. Look at that, we don't actually need the code. Why don't we take that out? Now we're practically at it being an iterator. Okay, so what time is it? 10:30. I think I can do a tiny bit more. Some tidying up. Sine, we're not going to do equality yet. Multiply, divide, semicolon, colon. So, another nice feature of Rust for someone who isn't doing it actually. So I don't know if it does. I don't think C compilers do this. Tells me which ones are not done, so I've just added a few in. I don't need to remember or bounce around. I just come down here. I go, okay, what did I want to match? Start, sum, token, multiply. Oh, I can't remember what I was doing. Oh look, I've got some others to add. So the compiler again is helping me out because it's listing ones not used. I know I need to put them in here. Have I missed any? Yep. Missed any? No. Let's go down here, make sure there's nothing too crazy going on. Times equals divide. And there you go. Next up is things like equality. Let's call it equals. That is a little bit more fun because actually that is good fun. We have to do self dot next, which is moving on, may mean that we need to be a peakable iterator. If let, look at the way I put it, if let some c that's probably a better way of doing it. That is terrible. It's verbose and verbose, and it's even more verbose. And excuse my extra parentheses, of course they're not needed. Consider removing this. Thank you, compiler. So remember we're expecting a divide afterwards, I'm worried it's going to miss it. Oh. Equals a sign, yep. Okay, what's wrong with this? Well, it's really verbose. If let some get the next one. Can't actually see how to shrink that in. There's nothing obvious because you're dealing with an optional type, you've got to break the optional type out. If you get some value in the optional type, then you have to still return the other case, which is a sign. Feels ugly. We're going to be doing that loads. In C, this would be a macro for code generation. So, where is Emacs? Look at Rust macros. Right, well, I think I'm going to call that a day. I'm going for an hour. I'm not super talkative. Which is why I actually started to do the stream, because I don't know why actually. I just thought I'd do it. No, seriously, I want to stream as much Rust as I can, just to maybe do some longer coding sessions. Obviously, it's in a very long one, only an hour, 20 minutes, but and yeah, I'm losing track. Obviously, very tired. Now, trying to get back into streaming. My streaming conversation, my stream of conscious thought that comes out my mouth is a bit jumbled, to say the least. And the streaming should let me try and what's the word? Straighten that out. But for now, I don't know what day it is today. Thursday. Unlikely to be back on tomorrow, but maybe I will. And hopefully that updated, but I'd left the old title there. As you can see, even though I haven't really programmed in Rust for a long time, I don't know the last time I had a run on it was, I have been reasonably productive. Made 100 lines, started to get a little lexer going, it's printing, it's doing its thing. We had no problems with lifetimes, which I have suffered with in the past. Once we got to the parser, I'm sure that will be a bit different. I had to think a lot about that before we yeah, not going to worry about that yet. We're not quite there yet. To get a better idea where we're going, we've got enough in the lexer to let's just add braces as well. think those are all the keywords I want to support. I want to do more, but it's starting to get quite late. Once we've got that going, we shall start to figure out how to write a little parser for it. A cursive to send parser, yep. And from there, we will then, maybe, if I don't give up, we will see what happens, but from there we will try and evaluate the syntax tree. The worst possible interpreter you can write, but that's cool. We won't add all these features in first, we'll just make it a simple calculator. Get the evaluation working, get some printing going, and go from there. So, as a return to Rust, I'm reasonably happy. I still like this. It takes away the boilerplate of having to write your own printing stuff. That's nice. Lifetimes, we didn't really think too hard. I don't know whether they've done some better stuff. I'm pretty sure you used to have to put a lifetime here and not here because they've got rules to elide the lifetimes there. But I mean, it's one parameter. I think the lifetime of this is assumed to be the lifetime of that. So some lifetime parameter elision or eliding. Eliding to omit. I always assumed it meant, but I thought I'd check. Not particularly felt slowed down. We got a little bit confused in here, but that's just lack of familiarity with the code. But the time we got stuck there, we saved by not having to write debug streaming operations for the token. This stuff is pretty nice, but no less nice. This is nice, but incidentally, if you program in C, there's a GNU extension that gives you something very similar, and I'm very surprised it hasn't made it into the language. Incidentally, again in C, there is a extension, a GNU extension, that lets you use code blocks where you use expressions, so you could put that and then return the last value. It helps make macros a little bit better, but it also is reminiscent of C, of Rust, in the sense that you get return values from code blocks. That is that. Right. Ooh. Excuse me. That is the end of today's stream. I'm going to stop it there, and hopefully, I suppose I'm going to say is I'm not streaming everything on the stream, but if I sit at my desk and I'm going to be doing some coding and I'm counting all little distractions, then I will probably kick off a stream. Right, I'm going to stop streaming there, and until next time.